Welcome class to our second video on our geometry unit. Yesterday you explored with Mr. Angen the ideas of perimeter and area. So we're going to talk more specifically and use some formulas for the area of some quadrilaterals today. I say some because we're not going to use the formulas for all the quadrilaterals. One quadrilateral in particular, the trapezoid, Mr. Angen will talk about with you tomorrow. We're going to talk today about squares, rectangles, parallelograms, and rhombuses. So if you have not yet done so, please pause the video, write down the topic, essential question, make your columns, and you can get down these formulas. Starting with squares and rectangles, you may remember the formula for the area of a rectangle is length times width. Now, length times width just means you're taking the two dimensions of the rectangle, multiplying them by each other. Doesn't matter which you consider the length and which is the width, because order doesn't matter with multiplying. So we can just multiply the two dimensions. Now, as a reminder of why we do that, let's think about trying to fill up this rectangle with little 1 centimeter by 1 centimeter squares. Okay, I did that over here on the right. So if we drag this over, we see that if this rectangle is 8 centimeters by 2 centimeters, we could fit in 8 of these square centimeters in a row, and we could fit in 2 rows. So 2 rows of 8, 2 times 8 gives me 16 square centimeters. So that's why we multiply the length and the width. We're multiplying how many you can fit in a row by how many rows you have. Okay, a little quick visual there. So you may remember that from earlier. You may not have remembered parallelograms and rhombuses. The nice thing about that is the same formula. Here I wrote it as base times height, but it means the same thing as length times width. We're just multiplying the two dimensions of the parallelogram or rhombus, but we got to be a little bit careful with the dimensions. Okay, maybe surprising as to why it has the same formula, but think about this. If you were to take this parallelogram and cut off this triangle at the end and move it over here, I've outlined where it would go. If you cut this off and moved it over here, what you would end up with is actually a rectangle, okay, that has the same, this for your base, and this straight up for your height. Okay, and that's the same space. Just by moving this over here to not change how much space it has. Okay, so that's why it's the same formula, base times height, but when we're dealing with the height, we need to make sure that the height has to be perpendicular to the base. Like this, has to go straight up from the base. So we would never consider this slanted side the height. It's the straight up and down side. Same with the rhombus. We could consider this base and then this the height. We could have the line on the inside or on the outside, it doesn't matter, as long as they're meeting at a right angle. Okay, so in each case, we're going to multiply the base times the height. So let's start by trying with a rectangle. So this rectangle is 20 feet by 12 feet. They're already meeting at right angles, so all I have to do is multiply. 20 times 12 is 240. So the answer is 240 because it's area, as you discussed yesterday. The units are always feet squared. So 240 feet squared for that rectangle. Okay, looking at a couple of parallelograms. Here we got things measured in centimeters. My base right down here is 5.3 centimeters. And when we go for the height, remember we can't use this 3 because this is not straight up, it's not perpendicular to the base. We would have to use this dotted line here that is perpendicular to the base. That's what this right angle sign means. So this is the height, this is how tall the parallelogram is, this is the base. So we would do 5.3 times 2, which would give me 10.6 centimeters squared. For the second example, here the line is drawn outside, but remember that doesn't matter. You see that the line and this line that I drew extending the base are meeting at a right angle. So these are perpendicular. The base is 13. The height straight up is 3. So 13 times 3 gives me an area of 39 centimeters squared. Okay, we're going to pause here so you can try a couple on your own, and we'll move on. Okay, looking at one quick word problem involving areas. Let's see how it goes. Jasaba drew a parallelogram with a base of 4 inches and a height of 3 inches. So I'll mark the base here 4, the height here 3. She then drew another parallelogram with the same height, but with a base 3 times as long as the original. Find the area of the new parallelogram. Well, to find the area, I need to know the dimensions of this one. So it tells me the height is the same. so the height is going to be 3, just like it was over here. If the base is 3 times longer, then I take this base of 4, multiply it by 3, that tells me that this is 12 inches. Okay, so if I want to find the area, I just multiply 3 times 12, which gives me 36 inches squared. I always square units with area. Now, if we compare that to the area of the original parallelogram, which is 3 by 4, the area of this one would be 12. You might notice that the area of this one, the big one, is 3 times bigger. Okay, so the area here is 12. The area here is 36. If you think about how many of these smaller parallelograms you could fit into the bigger one, you might be able to tell that you can fit 3 side by side, since this one is 3 times longer than this one. So hopefully it makes sense that the area is 3 times bigger, since 3 of these would fit into this. Alright, we are going to end our video today by giving you a few problems from the homework to make sure you're able to do this alright, and then we will conclude our video. So give these ones a shot. Good luck. Alright, hope those problems went well for you. In conclusion, make sure to contact your teacher between 10 and 12 or 1 and 3 if you have any questions on the concepts in this video. And I'll see you in the next recording. Bye.